Right now, in total silence, trillions of dollars, billions of messages, and nearly half of humanity's daily life are flowing through the internet. We think of the internet as wireless. We think about satellites and Wi-Fi, but the truth is much more grounded and much wetter. The majority of internet traffic doesn't travel through the air. It travels through a massive, fragile network of fiber-optic cables resting on the dark abyss of the ocean floor. If these cables were to vanish tomorrow, the global economy wouldn't just slow down, it would stop. This is the story of what happens when the internet backbone breaks, and how close we've come before. To understand a collapse, we first must understand the architecture. The internet isn't a single entity, it's a network of networks. Tier 1 providers such as AT&T, Verizon, and Lumen Technologies own the fiber-optic trunks that span continents and cross oceans. These trunks are the backbone. There are over 500 active undersea cables worldwide, spanning more than 1.4 million kilometers. That's enough fiber to wrap around Earth more than 30 times, and nearly all global internet traffic depends on them. You might imagine these cables are the size of tunnel-boring machines, but in reality, the core of the internet, the part that actually carries your data, is a cluster of glass fibers no thicker than a human hair. But the ocean is a hostile place. To protect those tiny strands of glass, engineers wrap them in layers of defense. First, a coating of petroleum jelly for water resistance. Then, a copper tube to carry high-voltage power. Finally, layers of steel wire, aluminum, and heavy polyethylene. Near the shore, where anchors and fishing nets are a threat, the cables are armored and buried. But in the deep ocean, where it's just silt and silence, the cable is surprisingly thin. It's an engineering paradox. The most powerful communication network in history is, physically, just a very long, very expensive garden hose. How do you lay thousands of miles of cable across a mountain range at the bottom of the sea? It starts with a cable-laying ship. These vessels carry spools of cable so large they can weigh several kilotons. It's a slow, meticulous dance. The ship must follow a pre-surveyed path to avoid underwater volcanoes and steep trenches. But there's a problem: physics. Light signals degrade as they travel through glass. Every 50 to 100 kilometers, engineers must install a repeater. These are essentially signal boosters. Because there are no power outlets at the bottom of the ocean, the cable itself must carry up to 10,000 volts of electricity just to keep these repeaters running. One mistake in the waterproof seal of a single repeater, and a billion-dollar project is dead in the water. Despite the armor, cables break about 200 times a year. Usually it's a ship's anchor or a localized underwater landslide. When it happens, the internet doesn't necessarily go down, it reroutes, but speeds plummet and latencies spike. In 2008, multiple submarine cables in the Mediterranean were cut within days of each other. Countries like Egypt and India lost up to 70% of their international connectivity. Financial markets slowed, businesses froze, and call centers went silent. In 2022, a single cable cut near Marseille caused a massive connectivity drop across Europe, Asia, and Africa. Fixing a broken cable is the job of the crew on specialized cable repair ships stationed around the globe. To find the break in a 3,000-mile cable 2 miles underwater, engineers use a clever trick. They fire a pulse of light down the fiber. By measuring exactly how long it takes for the light to echo back from the break, they can pinpoint the location within meters. Both ends of the cable are pulled to the surface, and in a pressurized, dust-free room on the ship, they splice the glass fibers back together. It's brain surgery performed on a swaying ship in the middle of the ocean. But the most critical threat to the internet backbone is at the exchange points. These are the physical buildings where different networks meet to swap data. If a major exchange point goes offline due to a cyber attack or a massive power failure, it creates a black hole in the routing table. The internet tries to find a new path, but the surrounding roads immediately become overwhelmed, leading to a total cascading failure. If the backbone suffered a catastrophic multi-point break, the timeline of collapse would be rapid. Within the first hours, we would have complete digital isolation. Apps would stop working, but more importantly, the border gateway protocol fails. This is the internet's GPS. Without it, data packets have no idea where to go. Next, our just-in-time economy starts to break. Logistics companies can't track shipments. Warehouses stop fulfilling orders. Within hours, the financial markets freeze. High-frequency trading relies on microsecond latency from the backbone. Without it, global banking enters a forced slowdown or complete stop. Within a day, we realize how much of our physical infrastructure is actually digital. Water treatment plants, power grids, and emergency services all rely on backbone connectivity for remote monitoring. We aren't just losing Netflix, we're losing the ability to manage the physical world. How do we recover from this event? Stay tuned for the answer, and don't forget to subscribe to this channel for more fascinating videos on the hidden systems of our world. You may wonder why we haven't had more failures if it's this fragile. The internet's core strength is redundancy. The internet uses something called mesh topology, built in by engineers to give the system resiliency. If one cable snaps, the traffic is automatically rerouted through 5 others. The system is robust, but it is not invulnerable. If several cables were disabled simultaneously or a major exchange point is damaged, recovery could take weeks. Today, the players are changing. It's no longer just telecom companies laying these lines. It's Google, Meta, and Amazon. They aren't just using the internet, they are building the physical foundation of it. This has turned undersea cables into a geopolitical front line. In a world where data is power, these cables are the ultimate target for espionage or sabotage. We are entering an era where cutting the cord could mean blacking out an entire nation's economy. The internet backbone is a marvel of human engineering, but it's a reminder of our dependency. We've built a modern world on a foundation of light and glass. It is remarkably resilient, but as we've seen, it only takes one anchor, one earthquake, or one bad line of code to remind us how connected and vulnerable we really are.